Well, Happy New Year to everybody. We are starting this Monday off with a cold, rainy morning, and it doesn't look like this week's going to be much but cold, so you'll need some sweaters and sweatshirts this week. So we're going to start our last method of systems of equations. It's called elimination. So elimination is a method for our systems of equations. It's one thing that we could do to figure out the intersection point of these two lines. We've talked about substitution and graphing so far, and our third process is elimination. So when we eliminate, the first thing we notice is elimination is best used when both equations are in standard form. So anytime you see this standard form, which remember, standard form is when you have the x and y together on the same side of the equals. You have your constant over here. Okay, so the first thing we want to do with elimination is we're going to line them up, and it really doesn't matter which one you put on top and which one we put on bottom. So I'm just going to write 2x plus 3y equals 15, and then I'm going to line up my x's and my y's. It's really important that the x's line up, the y's line up, and then your constants line up. Okay? So now just looking at this, here, if I add these together, this would give me 6y. But if I add these together, I would get 0. And that's what I'm looking for. I'm trying to eliminate either the x or the y so that I can identify the variable. So on this case, there's nothing to do with these other than to add. So we're going to just put a plus symbol here and a line, and I'm going to add top to bottom. So I know 2x plus 4y equals 6x. I know 3y minus 3y is 0. And then 15 plus 3 is 18. So 6x plus 0 is just 6x equals 18. And then here I can just divide by 6. And I know x now equals 3. So again, we're finding this intersection point here. So I know that my x is 3, so I'm missing the y here. So now that I know x is 3, I can pick either one of these equations and plug 3 in for x. And it doesn't matter which one I use. I don't know, this top one looks a little simpler to me. So I'm going to use the top one. So I'm going to do 2 times x here, which I now know is 3. So I'm going to plug in 3. Plus 3y equals 15. So I know that becomes 6 plus 3y equals 15. I'm going to subtract my 6. 6 minus 6 is 0. Subtract my 6 here, and I'm going to get 9. And then here I have positive 3y left. And then if I divide by 3, I know y equals 3. So in this case, these two lines intersect at 3, 3. Substitution method wouldn't work very well here, and you could always use graphing, but if you're going to graph, you have to solve for y on each one of these, which is probably just as much as work as this, so this is an alternative to that. Okay? So elimination is one of our methods, and the idea behind elimination is to eliminate one of the variables, either the x or the y. You just look to see which one's easier. And then you can find the variable value of one of those variables, and then you have to plug back in to find the other. So let's look at another example here. Here I have two linear lines. I can tell because they're linear because they're in standard form. So again, I'm going to line these up. I have x plus 3y equals 10, and then I have 3x plus 2y equals 9. Now, looking at this, these aren't going to eliminate as they are, and these won't eliminate as they are. If I were to add them, I'd get 4x and 6y and 19, and I can't solve for x or y. So I need to create a situation where these would eliminate one. So if I look at this, here this is really 1y, but I could easily make this 3y. If this was, 3x. If this was 3x and I subtracted them, these would eliminate, right? So really there's a 1 there right now. And I want to change this into a 3. So I know that if I multiply by 3, it'll become a 3. But if I multiply this by 3, everything has to get multiplied by 3. Okay? So I'm going to multiply the whole top line by 3. So then I'll get 3x plus 3 times 3 is 6y equals, and most people forget this, but don't forget the 3 times the 10. And if it helps, I would draw lines that you multiply each one to here, and that would give you 30. Okay? Now, I can just rewrite this line, and I can get these to cross out if I subtract them. So if I subtract them, I have to subtract everything. So I'm going to subtract that, subtract that, and subtract that. So now I have 3x minus 3y is 0. I have 6y minus 2y is 4y. And I have 30 minus 9, which is, what is that, 21, right? Yeah? Sorry? Yeah, that's right. Okay. That doesn't look real nice, does it? I think they would have gave us a nicer one. Oh, that's because I made a mistake. See? Good thing that we're doing this together. What is 3 times 3? I did what you guys do all the time, and I added those instead of multiplying them. Bad, Mrs. Thompson. All right, see? Good example that teachers make mistakes too. So this would be 3 times 3, which would give me 9y, right? So this would actually give me 7y. I knew that because I thought this should end a little nicer than it was going. So then we just divide by 7, and we know y equals 3. So here we have 3. Now I need this one, the x. So again, I know y equals 3, and I can choose either one of those equations. It doesn't matter. I'm going to do this one because it looks easy. So it's going to be x plus 3 times y, which we now know is 3. So that's x plus 9 equals 10. What plus 9 equals 10? 1, of course. So my intersection point is going to be 1, 3. Okay? Now I want you guys to try this one. See if you can do it. Line them up. 5x plus 2y equals 24. X plus 3y equals 10. So looking here, you should be looking here. What number can I put here so that these would cross off? Because these are two opposites. I could do these ones, but it's more complicated. So give that a try. See if you can come up with the intersection point, and we'll go over it first thing in the morning. Good night.